one characteristic of a good API is one that is highly performant and responds well to our customers' demands. So as developers, what can we do to ensure that we supercharge the response times of our APIs? Well, in today's video, we take a look at one hypothesis that might just hold the answer. Well, hello, wherever you are, whenever you are, where am I? Melbourne, Australia as usual, and when is it? It's February 2022. So what exactly is it that we're looking at in today's video? Well, today we're going to be taking a look at whether, note the use of the word whether we should be using Redis as a primary database with a .NET API with a view to improving performance and really supercharging those response times. Interesting question indeed. Now, if you've not used Redis before, that's okay. We go through everything, including all the code, completely step by step as usual. If you have used Redis before, then I'm sure you've got a lot of questions for me, and I'm hoping we answer all of those as we move through today's video. Before we get started, just the usual housekeeping stuff. The code is on GitHub. I'll put the links below and you can download the code if you want, but I do recommend following along. There is also a blog article, a companion blog article, so if you want to check out that instead, go and take a look at that. If you like the video, please give it a like. That just helps me out with analytics and all that kind of boring stuff. And if you haven't done so already, maybe consider subscribing to the channel, ding the wee bell, and you'll get notified of any updates. This year, 2022, I'm really making a big effort to produce a lot more content. Last year, maybe for obvious reasons, it was a bit of a crazy year. Didn't make that many videos. I'm hoping to change that this year, so a lot more content's going to be coming out, and if you want to be notified of that, yeah, just remember to subscribe for notifications. Other than that, there's not much else to be said, except I hope you really enjoy today's video, and yeah, let's get started. So yes, hello and welcome to episode 2 of season 5. And yet today we're going to be looking at using Redis as a primary database with a .NET 6 REST API. And really we're exploring the question whether this is a good idea or should we do it. Can we? But we can do it, but should we do it? Is it a good idea? So that's really what we're exploring in today's video. So this is what we're going to cover. We're going to look at caching to begin with and why Redis is used so much in that space. It's synonymous with caching. So while we're not implementing a caching solution today in code, we're going to go over the theory, and I feel that will give you a good background as to why we're attempting to do what we're doing today, which is using it as a full-on primary database. We'll cover Redis data types, a bit fluffy to begin with, just kind of cursory to begin with, but then as we move into the video and we start coding, we'll look at them in much more depth. Some of them anyway, not all of them. We will set up Redis in a container in Docker. Now that is totally optional. If you have another instance of Redis running in some other way, that's fine. You don't need to use Docker. I'm just choosing to use it because it's a nice ubiquitous way to set up something, and it's really simple as well. And then the main part of today's video, which is the building of an API in .NET using C# with Redis as a database. So if you want to follow along with today's video, you'll need the .NET 6 SDK, which is free. You'll need a text editor. I'm using VS Code, and I recommend VS Code, which is also free. We're API client, so we're building an API and we want to obviously test that API. The two main ones, or the two ones I'm most familiar with, are Insomnia and Postman. You can use either. I'm going to use Insomnia in today's video. And then this is optional. If you have some other way of running Redis, that's fine. But if you don't and you want to follow along, then you'll need Docker or Docker Desktop, and both of those are free. And this is totally optional. I am just using this tool as a teaching aid. It's a graphical user interface for Redis. And if you've not used Redis much before, it's a good way of representing how data is stored in Redis. I quite like it for that respect. in that respect, should I say. It was called Redis Desktop Manager. I think they've renamed it recently to RESP. I did pay for my version. I just went onto the Windows Store. It was like $15 or something, but I think you can still get it free. But again, totally optional, not recommending that you necessarily install it. We'll be doing most things at the Redis command line or in code. So what is Redis? Good question if you've not used it before. So at its heart, and this is an oversimplification, don't get me wrong, it's a key value store, okay? You store data based on a key and you store a value and you can retrieve data based on the key as well. Very much an oversimplification. When you start looking at the different data types, it does get more complex, but fundamentally that's what it is. It's synonymous with caching because it's so fast. And yes, it has a reputation for being incredibly fast due to the fact that Redis itself as an application is very lightweight, it's very lean, it's not a big bloated massive application, it's very light. Key value retrieval, which is fairly simplistic. You're not doing massive long SQL queries with multiple table joins and all that stuff. It's, you know, fairly lightweight key value retrieval. And most importantly, everything is stored in memory, so retrieval is super fast. Let's take a quick look at some Redis data types just to start to get you familiar. We're not going to cover them in depth here. We'll cover them in much more detail later. So strings. The simplest form of data that you can store in Redis. So you provide a key, which is an identifier, and then just a string of data. And we'll work with strings in today's video. Any of the data types that have an asterisk next to them are data types we're going to be working with. So strings we'll look at. You will hear about lists, and list is a concept of a list. Forgetting Redis is a very common data structure within computer science, and I'm sure you've heard about popping things off lists and putting things into lists. Redis has a list data type that we're not using today, but worth mentioning. Hashes we're going to work with a bit later. I'm not going to say any more about hashes for now. We'll cover those later. Sets, similar-ish to lists, but the sets are basically unordered lists of strings, and you can do all sort of set-based, not surprisingly, operations on sets. So again, you know, a very fundamental concept in computer science. And we will be using sets. And you have sorted sets. So again, the basic set is unordered, sorted sets are ordered, and you might use those in a different scenario, different use case. We're not covering those today though. More information here on data types, and I'll say it a few times throughout this video, the Redis documentation. I know people go, I don't want to read documentation. The Redis documentation is excellent. It's straightforward, easy to read, it covers everything, it's not confusing. Awesome documentation. I definitely suggest you take a look at this this page here, this document here, to look at the intro to data types. Really good. I'll put a link below. So Redis keys are such a fundamental part of Redis, it's probably worth just covering them at a high level here, but don't worry, if you don't follow this, well, it's not that complex, but you'll see how they work when we come on to coding. So the binary safe, which basically means you can use any binary sequence as a key. You can store lots of data as a key, but very long keys are not a great idea. In fact, the maximum size I think is 512 megabytes. That would obviously have a memory impact if you're using keys that were that size. So Redis don't recommend you use the maximum size, and there may be some performance issues if you use keys that were that big. Very short keys are not a good idea either. You want to make your keys balanced so that when you look at the key, you kind of understand what it's representing. Fundamentally, that's what you want to do. You want them to be kind of self-describing. So a good recommendation from Redis is that they should be readable with some kind of structured schema. So very common, and this is the pattern we'll be using today, is the object type that you are working with. So books or users, or in our case platforms, colon followed by some kind of unique identifier. So in this case on screen you can see user, colon, and the number. So you can look at that and go, I can understand what that's representing, and you'll see how all that manifests as we move through today's video. All right, so let's come on and take a quick look at caching, because to discuss what caching is in the context of Redis is actually a good introduction to asking the question, could we use it as a primary database as well? So let's go through a few scenarios where caching is not and is involved. So let's take a look at a very simple topology where there is no caching involved, and you'll probably be familiar with this topology if you've watched any of my videos. It's kind of what I usually do. So we'll have a client app in the context of today. That would be Insomnia or Postman or even a web browser. We'll have our API, which we will be building step by step today. And we'll have a database. So think of a traditional SQL database like SQL Server or Postgres or something like that. So the client will reach into the API or reach out to the API to fetch some data. The API in turn will then go to the database to retrieve that data. There will be some database fetch time while the SQL query executes and the data is retrieved from possibly on disk, possibly not, but while the data is retrieved from the database. That data will be returned to the API, and then the API will in turn return it to the client app. So we have a database fetch time, and we have also a total request time where you take into account network latency and all that sort of stuff. Very simple, very straightforward. What's wrong with it? Nothing. Nothing's wrong with that. In the context of a demo application or a very small application, this will work fine. In the real world, in production environments, as your data sets get larger and larger and larger and you get more and more users, this is possibly going to start to break down a little bit and slow down a bit. And so what you will want to do in terms of one of your optimizations is introduce a cache. And the point of a cache is to store data, frequently used data by the application that doesn't change that much. So the data itself doesn't change a lot. So it might be like a list of countries or something like that is still frequently used by the application. And so cache can serve up data much quicker than a database can. So let's take a look at that. So we've got the same three actors. This is our no-hit cache example, and I'll explain what that is by going through the example. So let's introduce our fourth actor, our cache, in this case Redis. And so same as before, the client talks to the API to get some data. The API in this case attempts to get the data from the cache in the first instance because it wants to do that because it believes it's going to be a quicker response time. In this case, we don't get a hit. The data it wants is provided a key to get the value back. It's not there, there's no hit. So it has to resort to the same cycle that they used in the last slide where it reaches out to the database. There's a database fetch time. The data is returned. We'll probably want to cache that data for future use in case we get another request for it, and then the data is returned to the client app. And of course, we have a total request time. Now, these timelines are slightly exaggerated. To be honest with you, the total request time on this slide versus the previous slide is probably not going to be that different, all other things being equal, because the interactions with the cache are really so very fast that it's going to be quite negligible, I think, the total response time, the total request time. Will be slightly longer though. So let's move on to our last example where we get lucky and there is a cache hit. So client app talks to the API, API goes to the cache. In this case, this scenario, hooray, we get a cache hit. There's this cache fetch time, which is really small. The data is returned to the API and then the data is returned to the client. And then we have our total request time. So very similar interaction to what we've seen before. The only difference is that the amount of time it takes for the cache to respond is greatly reduced. All right. So it does beg the question, do we need a database? And we ask that question because if we take a look at our very first example where we only had a database, you'll see the interactions that you're now very familiar with. And we look at our example where we had a cache hit and let's say the database played no part in it, you'll actually see the interactions are exactly the same. The only difference is that on one example we have the word database and on the other we have the word cache. So it starts to get us thinking, could we just use the cache as a database? So let's take a look at that. So Redis is a primary database, which is what this whole video is about. So Redis does more than act as a cache. It can also operate as a database, which is effectively what it is doing. It's a key value store. Again, I'll keep coming back to that. It's just a key value store. And so it can work as a cache. It can work as a database. It can even work as a message broker, although we won't be exploring that today. It does have a reputation, and rightly so, as an in-memory store. but that can mislead people into thinking that they would not want to use it as a primary database. Fine as a cache, because if you lose the data in your cache, well, you just go back through that cycle and go to the database because that has got persistent data. The thought of using Redis as a database is a bit worrying for some people because they believe that they will lose data should the Redis instance reboot or something like that happens to it. The main point I really want to get across in today's video is that Redis does offer a number of approaches to persisting data that we're not actually going to cover today. We're just going to use the automatic setup that it provides out the box where it does persist data down to disk as well. But that does not change the fact that the data is predominantly stored in memory still, and it is still super fast. But what it does mean is if we do reboot the instance, you have not lost your data. And therefore, it's a bit of a tick in the box to say, yes, it probably is at least worth exploring it as a candidate to use it as a primary database. And we'll explore that theme throughout the rest of the video. So yes, as it says there, you don't lose your data if Redis restarts. Now, I do want to just paraphrase Chris Rock a little bit, and he has said something along the lines, although there's a few bits of profanity in there that I won't replicate here, and he said something along the lines of, just because you can drive a car with your knees or steer a car with your knees doesn't make it a good idea. So again, just because we maybe could use Redis as a primary database, does it make it a good idea? You might technically be able to wrangle it to do it. Does it make it a good idea? Well, we'll answer that question at the end of the video as we move through. And maybe the answer is yes, maybe the answer is no. But again, just want to bear in mind that just because something is possible may not make it a good idea. But we'll come back to this question as we move through the rest of the video. Now, just to round up before we move on to actually starting coding, I just want to go over the application architecture very, very quickly. We have our client, which is external to our application domain. We will have our .NET 6 API service, and moving top to bottom, we will have a controller. We'll house a number of actions, and I'll show you those on the next slide. They'll be the API endpoints that we're going to implement. We're going to have a repository, which is basically an abstraction of our data, if you like. We will have a very simple model, which is an internal representation of our data, basically. And then we are going to have something called an iConnection multiplexer, and we'll come on to that when we actually move on to coding. I'm going to leave it there for the moment, but I just wanted to put it on this slide. And then we'll have our Redis database. Now, one thing I want to call out that I would usually put in a video like this is I would usually make use of something called DTOs, or data transfer objects. And if you're interested in what those are, then take a look at my other video on REST APIs. Basically, they are an external representation of our model. So we have a model there. Models really should just be used internally within an app. When we want to serve data out to the great wide world, we should basically use an external representation of that. And that's what a DTO is. In today's video, we're just going to be serving out our model, which is not really best practice, but in the interest of time, we're going to do that. But I just want to flag it that we're not using DTOs. As it says there, we are going to be using the iConnection multiplexer. We could use something else called the iDistributed cache, but I'll cover that in more detail when we come on to coding a bit later. And just before we move on with coding, I did want to just cover off the 3 endpoints that we're going to implement today. Now, before I even do that, I want to just cover off what our API is going to allow us to do, and that is work with platforms. What's a platform? A platform can be something like SQL Server or Redis or Docker. It's really just a list of platforms. It's like an application register. That's all. Super simple. Could be anything. Could be books, could be cars, again. Doesn't really matter. But yeah, that's what a platform in the context of these endpoints relates to. And we're going to have 3 endpoints. The first one, as you can see on the screen there, is the ability to retrieve an individual resource or platform based on its unique ID or key. Second endpoint is creating a resource in our database. And then the third endpoint is retrieving all our endpoints, all our platforms, everyone that's in the database. Now, you'll probably immediately think, there's a couple of endpoints that you could have also put in there, which is deleting a resource and updating a resource. And you're absolutely right, could have done that. Reason decided not to, 2 reasons. First one is time, but more importantly, the point of today's video is attempting to use Redis as a database. And these three endpoints that I've selected really help us to exercise or test out that hypothesis, because we're going to have to use different data types to kind of achieve these API endpoints here. By adding update and delete, we're not really going to be investigating any more around Redis data types. And if that doesn't really make sense, wait till we get onto these three endpoints and we implement them and we'll hit a bit of a brick wall and we have to reverse a bit and re-engineer it. You'll then come to realize why I've decided not to do update and delete. It's not going to add anything to our conversation. If you want to though, and by the end of this video, you should absolutely be able to implement those endpoints yourself if you want, just not going to do them in today's video. And so with that, the introduction is over. Still going to do lots of talking, but it's now time to start coding. All right, so let's begin coding. So the first thing I'm going to do is just open a new instance of Visual Studio Code, which will open on my other screen. So let me just pull that onto my screen that I'm recording on. And there we go. And I'm going to use the integrated terminal in Visual Studio Code. So Control backtick. That's the backtick key is the one under, well, on a US keyboard anyway, the key under the escape key. So I will move into my working directory to begin with, which just happens to be on my D drive. So it's D drive, season 5, and this is episode 2. Now you can obviously put your project anywhere that you choose. I'm just putting mine there. So before we even do any coding, let's just make sure that we have the .NET framework installed. So .NET -- version. And you can see that I have version 6 of the framework installed. And again, for this video, I strongly recommend that is the version that you use, just to keep things simple. We can then do a .NET new -- list to see a list of the possible templates we can use when we want to scaffold up our app. And we are going to be building an API, a web-based API, so no surprises. This is the template we're going to use. Now, in all honesty, to be really truthful with you, we could just as easily go for the empty template because we're going to delete most of the scaffolded code. But look, it's a very lightweight template anyway, so we'll just go with that. So clear the screen, bring the terminal back down, and we'll do a .NET new template name web API, and we'll give it a name. Let's call it Redis API and hit enter. And that was incredibly quick. So if we do a directory listing, you can see we have a folder in there. So if we just type code Redis API and use the R flag, then that will recursively open that project in our Visual Studio Code instance. So I'm just going to trust this. And we'll probably get a pop-up down here while it resolves some dependencies. We'll just wait for that to happen. And well, that's happened already, that's fine. I thought it would take a bit longer than that. Oh, there we go. It did take a bit longer. Yeah, just say yes to that. Fantastic. So moving into our terminal, we will just run this up just to make sure it's all working. It would be highly unlikely that it shouldn't be working, but you never know. Always worth checking these things. And what you get out the box is a very simple weather forecast API. So here you can see the model that the model class that we have, which just has some temperature attributes and a date attribute. And we have one controller, the weather forecast controller. And we're going to delete all this stuff in a bit of a later section. We'll leave it here just now. And yeah, we just have one controller action, weather forecast. So get action, and yeah, we just get some randomized weather data. So let's just use a web browser for the moment, just to make sure that's working. We will move on to using Postman when we move through the majority of the course. So let's just take a look at the HTTPS endpoint. And just a point of note, I've mentioned this before, I'll mention it again. In .NET 6, the port numbers for HTTPS and HTTP are slightly randomized. Actually all HTTPS ports begin with a 7 now, and all HTTP ports begin with a 5, but they are different every time you scaffold up a new project. So just copy that and we'll paste it into our browser, Edge in this case. And again, I'm just doing this to make sure it's all working. And we'll just hit the controller. And there we go, we get some JSON data back. So just doing that to check that it's all working, which of course it should be. There's no reason why it shouldn't. Okay, so we'll just do a Control-C on that. Now that's really our project, Scaffolding Up. Again, there's no startup class because we are using .NET 6. Everything is in the program class. Same principles though, you set up and register your services up here, and then you configure your request pipeline down here. So a bit more simplified without having a separate startup class. All right, now we're going to obviously we're going to come back and work exclusively within this project. But the next thing I want to do is set up Redis in Docker, and in order to do that, we're going to use a Docker Compose file, and we're going to put that Docker Compose file into this project. So we'll park this project kind of for now, and we'll come on to standing up a Redis instance in Docker, so we'll do that next. All right, so we're going to come on now and use Docker to run up an instance of Redis that we can use throughout the rest of the video. So you'll obviously have to install Docker. I'm not going to take you through how to do that. It's fairly straightforward, at least on Windows and Mac OS. You'll install Docker Desktop. Linux users, I'm not going to tell you how to install Docker because you're so intelligent. If you're choosing to use Linux, I'm sure you know what you're doing. You don't need me to tell you how to install Docker. And yeah, Docker Desktop on Windows and Mac is very, very easy. So assuming you've done that, the best way to check to see whether it's running, or one of the ways you can check to see that it's running, there are a number, is at a command prompt. Just type docker -- version and you should get a version returned back to you. Now, just on the subject of installing it, I will make a special call out to Windows users, and my recommendation, in fact, you need to do this if you want to follow today's video, is when you come to install Docker Desktop for Windows and you get a choice of possibly using Windows-based containers or Linux-based containers, make sure you go with the Linux-based containers. It's just a much better install pattern, and it'll save yourself a lot of problems, believe me. So go with Linux-based install. And if you're anything like me, you'll use the Windows subsystem for Linux as your kind of Linux backend. That would be my high recommendation for all Windows users. And in fact, Windows Home users, you'll have to go down that path anyway. But for me, it's still the best option. So that's the only points I'll make about installing. Mac OS and Linux users, you will be fine. Cool, so we have Docker up and running. That is looking good. So the next thing we need to do is create what's called a Docker Compose file. And Docker Compose is really, it's a nice way of scripting your containers, your running containers. If you don't use Docker Compose, you'd have to do everything fully at the command line. And some of these command line prompts can get quite unwieldy, subject to error, not really repeatable. So Docker Compose is a great way of basically scripting all that. So in our project, right click, new file, and we just call it docker-compose.yaml. And you should see a little pink whale next to the Docker file. Fantastic. So the first thing we need to specify is the specification that we're using. And anything above 3 should be fine. And I think at the time of writing, or the time of making this, the latest version was 3.8. Doesn't really make any difference, to be honest with you. Certainly not for the way we are using it. Then we want to specify our services, and our services are basically just a list of the containers effectively that we want to run. Now you could have multiple services in here. You could have Redis, SQL Server, Postgres, RabbitMQ. We are just having one service, which is Redis. Now you give it a name, can be anything you like. I'm just going to give it the obvious and call it Redis. And then we specify the image that we want. And this is the image that contains our Redis application. And if you've not done much with Docker, basically an image is like a blueprint for what you want to run. And yeah, that's basically the power of Docker. You know, you've got these pre-canned images, you just ask for one that you want, spin it up, and Docker will just run it. And you know, because it's running on Docker, you very, very, very rarely get any issues with just spinning up. It's awesome. Docker is one of my absolute favorite tools as a developer. So you just specify the name, in this case Redis. Now what will happen here is if I have the Redis image in my local machine, that will just be used and this will be super quick. If I don't have it, then Docker will go to the Docker Hub, which is just like an online repository of images, and pull it down for us. Now I can't remember if I have Redis on my local machine. We'll find out when we run it up. If it runs really quickly, then I do. If it takes a while, then we know it's pulling it down. But you'll see that happening at the command prompt anyway. You can give the container a name, and that can come in a bit useful later. So let's just give it a name, and we'll call it Redis API. Can be anything again. And then finally, we're going to specify some ports. And ports are really important because in order for us to connect into this running container from our API or from some other tool, we need to have an external port mapping that's mapped through into an internal port. And that's really what we're doing here, an internal to external port mapping. And the internal port is the standard port that's used for most Redis installations, which is 6379. And just to keep things nice and simple, I'm going to map that through to the same port allocation externally, and that's the port we will use externally when we come to connect in. So we'll save that off. And that's it, very simple. Just be careful with your indentation. It can get quite pernickety about that. If you have problems, the code is on GitHub. You can just pull down my Docker Compose file and use that if you have any issues, but you should be fine. It's pretty straightforward. Fantastic. So make sure that's saved off, and now what we're going to do is run it up, and this is where we find out whether we've got the Redis image on my machine. So just before we do that, do a directory listing and make sure you can see the Docker Compose file in your local scope, as it were. And then at command prompt, just type Docker Compose up to spin up our containers, and then optional but highly recommended -d. And what that means is we're running this in a detached mode, so when the container runs up, it returns back, as you can see here, it returns back the command prompt to us immediately. If we didn't have the -d flag, you'd have all sorts of output from Redis. Redis keeps control of our command prompt, but we've not done that. Now you can see that was super quick. You saw how quick that was, so that obviously means that we have the Redis image on our local machine. If you do this, and it's the first time you're using Docker, well, absolutely guarantee it will take a while for Docker to pull the image down, and it shouldn't take too long, okay? A couple of minutes, something like that. Fantastic. So although it's saying our container is created and it's started, I'm going to show you a couple of commands and a couple of tools you can use just to validate that. So quick clear the screen, and if you type docker ps, that will give you a list of running containers, and you can see here that we have one. And you can see, you know, a lot of the stuff that looks familiar to us. If you don't particularly want to do a lot with the command line, that's fine. What I would recommend you do is install this plugin for VS Code, Docker plugin. So if you come over to your extensions tab, I've already got it highlighted here, just type in Docker. It's from Microsoft, it's got 13 million downloads. It's a really nice wee tool. I use it all the time, and it just puts it in your toolbar here. What you will see are the running containers. And you can see here we have one running container, and then you can also see all the images that we have. Now you can see I've got a Postgres image, a RabbitMQ image, and probably a whole heck of other stuff as well. And that's why it was so quick. Already had the image there. That's cool. So it gives you a nice overview of what's happening with Docker. Now we can stop this using the GUI. So right click, stop, and that will stop that running container. And if we go back to our command line and do a docker ps, you'll see nothing is running. So we can either go here and run it here again, so docker start, or we can come back here and we can do a docker compose up, and it will spin up our container again. It's running again, and you can see the green arrow here. Now, just a couple of command docker compose prompts for you. If you type docker compose stop, any guesses what that will do? It will, of course, stop the container. And you can see there, the container is still there, it's stopped. Now, let's run up again. There is another command. I probably even shouldn't show it to you, but I've fallen into this trap. Colleagues of mine have fallen into this trap because you use the docker compose up command to spin containers up. Just in your mind, you kind of think quite naturally that the opposite of up is down. So if you type docker compose down, totally valid command, but if you keep an eye on what's happening in our container section there, you'll see what actually happens here. And you can see, not only does it stop it, it completely removes it. Okay, so that's fine if you want to do that, but my recommendation to you is to use Docker Compose Up and Docker Compose Stop. And the reason for that is, well, the main reason for it is you don't want to destroy your running container. So you might, and again, we'll do this, have data stored within your container. So if you do a Docker Compose down, it completely blows all that away. Whereas Docker Compose Stop, it retains it and you just need to restart it. Now, those are Docker Compose commands. You could also use native Docker commands that I'm not going to go into today. My other videos do cover that. But I think between those Docker Compose commands and the tool, if you're using VS Code, I think we've got it covered. Fantastic. Cool. So Docker Compose is done. We've got a running version of Redis, which is fantastic. So just before we come back to our project and start coding, what I want to do is we're going to dip our toe very slightly in using a couple of Redis commands. And those commands allow us to add data or set data and also retrieve data. And we'll do a couple of commands, super simple, just to get you across the concept. And then we'll move into coding and we'll actually make use of those commands in our code. All right, so what we're going to come on and do now is use a command line tool, a Redis command line tool, or the Redis command line tool to issue some commands to create and retrieve data just using the command line. So we're not going to be using code or anything like that just yet. Now, in order to use the Redis command line, we could install it locally. That is one option certainly, but I'm going to take a slightly different approach, and that is effectively to connect into our running Redis container and basically attach a command prompt to it. So we can just run commands directly inside that container. And obviously because we have Redis running in that container, we also have the Redis CLI tool installed as well. So it just means we don't have to install anything locally. So in order to get going with that, let's just get our container's ID. And the way you can do that is a command we have already used, which is docker ps to get a list of running containers. And we have our container here, and this is what we want, this container ID. So we'll just copy that. And then we type the following command, docker exec, and we want an interactive session. We'll paste in the ID of our running container, and then we just specify the path that we want to kind of start our command prompt from, effectively, or command prompt in. And you don't need to be a Linux expert to appreciate that the path we're specifying there is a Linux-based path. No surprise, because it's a Linux-based container. So let's hit enter, and we have now attached into that running container. So we're now really running in a Linux container, effectively. And then all we need to do is just start the Redis CLI command line tool, and all we do to start that is type in redis-cli, and it would help if you spelt it correctly, redis-cli, there we go. And the way you can kind of test that that is working, apart from the fact that the command prompt has changed, if you just type ping, we'll get a pong message back. So that's all looking pretty good. Now, just to labour the point, if I just bring over a command prompt, this is like a Windows command prompt, PowerShell command prompt. If I type redis-cli, it won't be recognised because I don't have it running locally. So we're running in our container. All right, fantastic. Now, before we move any further with doing anything else, I want to just come back to the concept of Redis data types, because it's worth just mentioning that we are going to be working with arguably the simplest data type in this exercise, and that is string. So let's just have a quick look at what we mean by strings. So yes, the simplest type of value that can be associated to a key, and it's really just a one-to-one mapping between a key and a value. Couldn't really be much simpler. So if you're used to using JSON, well, actually JSON's more complex. This is even simpler. It's literally a key and then a value, a one-to-one mapping. There's no nesting or anything like that. So JSON, forget JSON, that's a bad use case. It's literally just a mapping that you can see there on screen. Useful for a wide range of generic use cases, I'm sure you can imagine, and this is really what we want to get onto. You can set data using this set command, and that's the format that we will run in just a second. We will issue the set command at the Redis CLI with the key that we define and some value. And then you can return data using the get command, and you just say get and specify the key, and that will be returned back. The value will be returned back if there is one, of course. And we'll come on and do it actually, rather than looking at slideware. Let's get going with that, and we will start specifying some data. So let's set our first value. And the good thing with the Redis CLI is that it kind of gives you this help along the way. So we're issuing a set command. We are working with platforms. So again, if you remember from the slideware, the typical schema that you would use for your key is the name of the object or entity that you're working with, in this case a platform, and colon, and then the actual kind of numeric key value. You can just give it anything you like here. And then a value, let's make our first platform as Docker. We'll enter, we get an OK, come back. And then to return that piece of information, we issue the get command and just type in the key, and we get returned Docker. Fantastic. Now, before we go any further, I just want to show you some more excellent documentation from the people at Redis, and they have provided, if I just go back, they have provided a whole list of all the commands that you can issue at the Redis CLI, and you can search for the ones we've just used here. But what you'll notice is there's hundreds and hundreds of them, and as we come on to working with different data types, you'll see that we use slightly different commands for setting data when we are working with sets and as opposed to working with strings. And we'll use a different command to set data when we're working with hashes, but they all follow a similar kind of pattern. But we'll stick a pin in that for the moment. But again, I'll put a link to this documentation below. It's very, very good, very, very thorough. That's really about it. I mean, the only other thing I'll probably mention here, because we're going to cover this in more detail a bit later, is if we run the set command again and we issue the same key, just make sure I spell it correctly. I've spelled it wrong, there you go, I always do that. Form, that's the one we want. And we give it another value of Redis. It does OK, says OK, and basically if we do a get, it just returns Redis. So the point I'm making there is it doesn't complain by the fact you're trying to reset the data, it just overwrites it. So again, very, very simple. And then probably the only other thing I'm going to cover here is the delete command, and we just again type in the correct key value, and we get an integer result, 1, saying that we have deleted one key with that value, and if we attempt to get it, we get nil returned. So that's about it. That's our first sort of set of string commands. Now what we're going to do next is we're going to come on and we're going to start shaping our API project, and then we're going to come on to actually using these commands, but from within our C# application. So let's go on and start doing that now. Okay, now actually just before we move on to coding, I didn't mention how you can escape or exit from this command prompt scenario we've got here. So we're still connected in to our container and we're still using the Redis CLI. So quite simply, I'm sure you would have figured it out yourself, you just type exit, that will exit you from the Redis command line prompt, and then if you just type exit again, that will exit you out of the attached container, and we're now back in our local command prompt. So I'll clear the screen, and again, just repeating myself here, but we'll just double super check. If we just issue Redis CLI, we'll get an error as we would expect. Fantastic. Cool, so let's draw a line under that for the moment and come back over into our file explorer. And what we want to do now is to start to really think about building out our API application. And as usual, in projects of this nature, the thing you want to probably start to think about are any external references that you want to bring in, and this is no exception. So looking at our CS proj file, we're basically going to add a package reference that will allow us to work with Redis from within our application. Now the question becomes, what package reference, which package do we install? And it's a little bit ambiguous, certainly if you've not used Redis before, so I want to just kind of clarify that for you now. So you may see this package here, Microsoft Extensions Caching Redis. You may see that in online tutorials and documentation, all that kind of stuff. it is essentially deprecated. So don't use that one. It's no longer being supported. So I'm putting it up there purely just to get you to ignore it, okay? The next one you'll see is Microsoft Extensions Caching, Stack Exchange Redis. And the other one you'll see is Stack Exchange Redis. So which one of those two, number 2 and 3, which one of those should you use? Well, it really boils down to whether you want to use iDistributed cache to act as your layer of abstraction between your application and your Redis instance. iDistributed cache sits in the middle, or whether you want to use iConnection multiplexer. Again, it sits kind of in the middle between your code and Redis, and you can use either one. Why would you choose one over the other? Well, iDistributed cache is arguably, although I'm not sure I fully agree with this, well, it is technically, it's a bit simpler to use. It's a bit quicker to get up and running with, but the price you have to pay for that is that you are restricted effectively just to one data type. Okay, it's a lot simpler. You don't get the whole rich range of data types that Redis provides. You are restricted to one. If you want to use iConnection multiplexer, it's arguably more complex to set up, although I would say it's not by a huge margin at all, but you have all the data types available for you to use. Now, you know, in my mind, it's a no-brainer. We're going to go with iConnection multiplexer, so that's ticking the box for that. Now, actually doesn't really go back and answer a question, to be totally honest with you, because both package number 2 and package number 3, both of those support iConnection multiplexer. So really, which one you want to use, you can use either of those. If you wanted to use iDistributed cache, certainly at the time of writing, when I was looking at this tutorial, when I was making it, only package number 2 supports the iDistributed cache. The Stack Exchange Redis package does not support it. So if you want to go down that path, which we're not in this video, then you would need to use number 2. Now, as it happens, we're going to go with package number 2 anyway, and it's really just a matter of personal preference. The reason I am opting for that package is because I just like to use the official Microsoft packages, really. That's about it. And in fact, if we come over to NuGet site and we just search for Redis, you'll see Stack Exchange Redis, and it is definitely the most popular package, so feel free to use that. It's 121 million downloads. And then we have the Microsoft Extensions Caching Stack Exchange Redis, which has 19 million downloads. And this is the one we're going to use here. If we click on that and we look at the dependencies, you will see it actually makes use of Stack Exchange Redis anyway, okay? So we're going to go with this one here. So I'm just going to copy that. I've got .NET CLI tab selected because that's what we're going to be working with. I'll just click copy and we'll move back over into our terminal. I like to have the CS proj file open and we'll just paste that in. I'm going to remove the version specification just because if you use this format, it will go away and get the latest version anyway. So run that and we should see package reference being added to our CS proj file, which indeed we do. So let's just clear this up. And the other thing I want to do just while we're at it is remove the scaffolded stuff that we don't need. So the weather forecast model, I'm going to get rid of that and delete that. Yep. And although we will be writing our own controller, I'm going to write it from scratch. So we're just going to delete the weather forecast controller as well. I'll move that to the recycling bin too. So what we now want to think about doing is we actually want to connect into Redis. And if you've done anything with SQL Server or any database for that matter, it's not going to come as a huge surprise that we use a connection string to connect in to our Redis instance. So let's set up our connection string first. And where I'm going to do that is just in app settings.development.json. Now I'm going to come in here, I'm going to put a comma after this block of objects, and I'm going to specify the connection strings parameter. And then in connection strings, I'm just going to specify our Redis connection string. I'm just going to call it Redis connection. I think that's a decent enough name. That can be absolutely anything you want though, but just remember what it is because we'll be coming on to using it a bit later. And then colon, and then the value of that particular connection string. Now in this case, it's going to be localhost, but we're just going to use the loopback address, so 127.0.0.1, and then the external port mapping that we had created in our Docker file. our Docker Compose file, which is 6379. So if we come back over here, it was this port here. Okay, so we're just specifying that's the port we want to connect into. Important to use, and you even saw it when I was typing it out, Visual Studio Code suggested that this was what I was wanting to use, and indeed it is, and we will make use of that a bit later. So save that off, that's effectively our connection string config done. And then the next thing we want to do by way of setting up connection is we want to make use of our iConnection multiplexer. So the way we do that is by registering it in our program class as a service effectively, as a registered service. So I'm just going to add it as a top level item here. So let's begin. I'm going to make access, make use of Builder to get access to our services. And then we're going to add a singleton of what type? We are going to add a single of iConnection multiplexer. And I'm hoping I've spelt that correct. Now, it won't know what that is. I think I need to put one more N in there, iConnection multiplexer. We do a control period. I think I probably spelt that wrong, so let me just double check. Multiplexer. That's better. So control period. There we go. And we get this using statement. So we can remediate this error a number of ways. The way I'm going to select is this introduction of a using statement. And you can even see the namespace that's being used. It's just using the Stack Exchange Redis namespace anyway. Okay, so that was control period to get that. Obviously, I had spelt that incorrectly, and when I tried to get code resolutions, it didn't find any appropriate ones to solve our given problem. So, fantastic. And then we're just going to use a bit of a lambda expression just to configure some options, namely the connection string that we want to use to configure our connection to our Redis instance. So I'm just going to take a new line, and the old tooltips are great, but can be very annoying. And I'm going to make use of connection multiplexer. There we go. And connect. And then we want to supply the connection string into this method here. So I want to just round out this line. And then here we want to feed it the connection string basically. So I'm going to do it in a slightly long-winded way. I'm going to make use of Builder again, and then I'm going to access the configuration object on that. And then on that, I'm going to make use of the get connection string method. And then into that, finally, we pass the name of our connection string. So we come back to our app settings development JSON file, and we want to supply this here. So we'll just copy that. And really importantly, you can store your connection strings in any way you like in this file. If you elect to use this method here, using the actual connection strings attribute name, then it means that you can make use of this get connection string method, as we are doing now. If you choose not to use it, then you would have to access the relevant configuration in a slightly different way. So I recommend this is the way you do it. Okay, so that is really the Redis stuff. By way of connecting and all that kind of stuff, connecting in and configuration, that's it really done. Although it's not working yet, we haven't done anything with it, but we're going to take a bit of a pause here before we move on to the next section, which is creating our model. But yes, for now, we're kind of done with our initial setup. And then next, we're going to start building out the actual features of our API, starting with our model. All right, so just before we move on to coding, actually, it might be worth just doing a bit of a sense check to see where we're at in terms of progress. So working from the bottom up on the diagram on screen there, our Redis database has been set up in Docker using Docker Compose, and it's all up and running, and we've even used it. So that's tick in the box. The iConnection multiplexer, as you saw in the last section, there really wasn't that much to setting up. Package reference, connection string, and then registering it in our dependency injection container. Pretty straightforward. So unless we've made some weird mistake in the connection string or something, we shouldn't have to touch that again. So that really just leaves us with our model, which we're going to come on to next, our repository, and our controller. Now, in terms of novelty and in terms of Redis, interesting Redis code, most of that, if not all of it, is going to sit within our repository implementation, because the repository is actually going to be using the connection multiplexer to talk to Redis fundamentally. And the whole point of a repository pattern is that the controller, the consumer in this case of the repository, is absolutely oblivious to the fact that it's using Redis as a database. It does not care. It's just going to use an interface that we're going to write ourselves. And it could be using SQL Server, it could be using Redis. It doesn't know, it doesn't care. And that's the beauty of the repository pattern. So anyway, we still have model, repository, and controller to do. So let's move on to looking at our model next. All right, so let's come on and define our model back in our project. So in our File Explorer, right-click, New Folder, and we'll create a folder called Models. And now we're only going to have one model, but I like to just keep things organized in my code, unlike in my real life, which is a lot less structured than this. So in the Models folder, right-click, New File, and we create our platform model. So just platform CS. And again, I keep mentioning this, but I have a tendency to misspell the word platform, so just double checking that that's correct. Then as usual, namespace, which in this case is Redis API, and then we're in the models space, models. Cool, and then we just specify a public class called platform. All right, and our platform class is going to be very simple. It's just going to have two properties. An ID, which is really going to be our key in Redis terms. In maybe more traditional relational database terms, it would be our primary key. And the second property is going to just be the name of our platform, and we'll just call that name. So let's define those two properties in here. And short way of defining properties is if you type prop and then tab, you get this kind of template for a property. So the first one is going to be our ID. Now I'm going to define this as a string, and I'm going to call it ID. Now straight away you'll see we get a little warning. We'll come back to that in just a second. Let's just define our second property. So again, prop, tab, it's also going to be a string, and we'll just call that name, and that's again going to be the name of our platform. Super simple, okay? So I don't want to spend too much time on this, but I do want to just cover why we're getting warnings here. And for those of you who've used earlier versions of the .NET framework, if you define this class in exactly this way, you wouldn't have got these warnings. So what is going on? Is there something new in .NET 6? Yes and no to that. So what is new is if we come over to our CS Proj class, what is new is the inclusion of this here, this nullable enable. And really what that is doing is enabling warnings like we're seeing in our platform class. It's enabling them, it's enforcing them. And what that means is the compiler does what's called static code analysis, and it looks at our code and basically it tries to pre-warn us when we may, in this instance, get null reference type exceptions potentially. And so it's picking up and saying, look, the way you've defined these two strings, which are reference types in C#, may return null at some point and you may get some kind of error. Now, what you can do is define some strategies here to deal with these warnings. Now, one strategy would be to remove that bit of config from the CS Proj file. Not going to do that, I'm going to leave it in because I think they're actually, although they can be a bit annoying, probably valuable to have them there. So what can we do? Well, in their infinite wisdom, Microsoft have actually provided a number of techniques for dealing with these nullable warnings. And there's also an article on nullable reference types, which were, as it says there, they were introduced in C#8. So nullable reference types aren't a new concept. They've been around for a while, but what is new is that enforcement of warnings in our code. So again, down here, how do you resolve nullable warnings? I'll let you read all about that. Fantastic. So we're going to resolve these warnings in a number of different ways. So the way we're going to do it is by basically assigning values, default values to these two properties. So we'll deal with the first one, or the second property, but we'll do it first because it's a simpler use case. And all we're simply going to say is it's going to be set to an empty string. And the warning should dissipate, as you can see there. Now, again, there's lots of strategies for dealing with this. I'm just going to take this approach because it's simple and relatively straightforward. You could, let's see if we took that out, we'll get the warning back. You could specify this as nullable if you put a question mark in there. That will get rid of that. But I'm not going to do that. I'm going to use this approach here and make it equal to string empty. All right, cool. Now for this one, and again, just to label the difference between reference types and value types, if we define this as an integer and not a string, you'll see the warning goes away because integers can never be null. Okay, they are value types, whereas string, the reference type, in this case could potentially be null. And if you don't know what the difference between value types and reference types are, do a bit of Googling, again, kind of outside the scope of this video. So we're going to use the same technique here. We're basically going to assign a value to this. Now we actually want to do this anyway, and this is a really important point. It's a bit of a design decision when we're looking at using Redis. So taking Redis aside for the moment, in my other videos when I've defined a class like this, I actually have defined this property, the ID property, as an integer. And then when you ultimately migrate that class down into SQL Server, for example, what will happen is that that ID will manifest as an integer data type in a SQL table. It will be set as a primary key, so it's enforced as being unique. And also, certainly if you're using SQL Server, the ID column will be set as an incremented primary key. So actually SQL Server pre-populates the ID column with a value that's guaranteed to be unique. So you don't even need to pass an ID value with your code. It's done at the database level. Redis doesn't do anything like that for you. It doesn't generate keys for you. You have to supply the key. So we actually are going to have to do that here anyway. We're going to have to supply a value to this property anyway. And so it's got a double benefit. Number one, it's generating our key for us, and also it's going to get rid of this null reference exception. So the way we're going to do it is we're just going to say equals, it's a string, but we're going to use string interpolation. So put the $sign in there. I'll just terminate with a semicolon. And our key is going to follow the format that I've already talked about. We're going to declare, I just hit, what key did I hit? Hit F11 there. We're going to declare our key as having the prefix of platform, colon, and then the numerical component of that key. So the platform colon is still very much part of the key. It's still part of the key, but the additional numerical unique part is going to be just a GUID that we generate on the fly. So curly brackets to work with some more dynamic code. So we're going to use the GUID class, and we're going to say new GUID, and then we're just going to set that to a string. And I think that should be good. Okay, so we're going to end up with a key of the format platform colon and then a GUID, which, as I'm sure you're aware, is a big long string of random digits and numbers, guaranteed to be globally unique. Okay, so that is our class. Actually, we've got one more thing to do, but that's basically the main part of our class defined. So we've got rid of our null reference type warnings, and we've defined our key, which is really important. The only other thing I want to do from an API sort of perspective is decorate these properties with required, so that when we come on to defining these or creating these platforms via our API, we know what items are actually required to be provided. So we need to bring in the namespace for that. So control period, and it's system component data annotations, and the same for this as well. Fantastic. Okay, so we'll save that off. We'll do a quick .NET build just to check that we haven't still got any warnings anywhere. And then we can move on to our repository, assuming everything is okay, which it looks like it is. Let me just make this a bit bigger. Yep, zero errors, build succeeded. One of the nicest things you can see as a developer, isn't it? Build succeeded with 0 warnings and 0 errors. And I hate warnings. I actually hate warnings almost as much as I hate errors, so that's why I like to get rid of them. Cool, so that's our model class completed, and now we're going to move on to working with our repository, which is arguably the most interesting part of today's project, because that's where all our Redis stuff, Redis code is going to go. So let's get started with that now. All right, so we're going to move on to creating our repository. So back over in our project, the first thing we're going to do is create another top level folder. So right click, folder, and we're going to call that data. Next up, we're going to create an interface. So new file, and we'll call that I platform repo.cs. Now, if you don't know what an interface is really just a list of the methods that will be available to you as a consumer of this interface if you choose to use it. There's no implementation there. It's literally just a blueprint or a template or an interface. And then the idea is that we can then write an implementation class that implements this interface. And when we then ask for this interface, as a consumer, we don't really get given the interface. Well, sort of we do. We actually get given the class that implements it. And you'll see how all that ties together. So the interface is really just a spec, really, for the methods that this interface exposes. So we'll start with a namespace as usual, and it's Redis API, and we're in data. And new line, curly brackets, and then it's just a public interface. And we'll call it I platform repo. And I'm just double checking my spelling of platform as usual. All right, fantastic. So let me just create our method signatures. Now, before we do that, I'll just quickly remind you, these are obviously our endpoints that we're going to implement. Now, the method signatures we're going to specify in our interface are very, very closely tied to what these endpoints are doing actually. So that's not always the case, by the way. Your repository interface may have many, many more methods, but in our instance, yes, there is actually going to be a one-to-one mapping. So just thought I'd call it out, but don't think that there is always a one-to-one mapping. Just in this instance, there happens to be so. So the first method signature I'm going to specify is going to return a void, nothing, and we're going to call that create platform. And as the name would suggest, it is this method that will allow us to, no surprises, create a platform. Okay, getting a bit tongue-tied. Void create platform, perfect. And into that we expect a platform model, and we'll call that plat. Fantastic. Now it will complain about not knowing what platform is, so control period, and we'll bring in the relevant namespace. Fantastic. So that's our first method signature. The next one is going to be a get platform by ID. So we're going to provide a key and expect back one platform. If there is one, we might get nothing back. So it's going to expect a platform again, and we're going to call that get platform by ID. And into that we're going to expect a key, which is a string in this case. We'll call that ID. And then the final one is our enumeration of all platforms in the repository, in the database. And so we'll use an IEnumerable. And what type is it? It's of type platform again. And we'll just call that get all platforms. And we don't need to pass anything into that. We're just saying, give me all the platforms. So that's our three method signatures. So that all looks good. Again, this is just an interface. There's no implementation, which is what we're going to do next. So that's our methods specified. So back over in data, if you right click the folder, new file, we're going to create a concrete implementation class for Redis that's going to implement these methods. So we'll call it Redis platform repo.cs. And the idea here is we could create another concrete implementation class for SQL Server or Postgres or something else, and you can swap those implementation details out. The consumer, again, you'll see this, our controller, is only interested in the interface, so it doesn't really care what's implementing it. It just knows that those methods will work for it. So that's the idea behind it. It's a very cool concept. Now, this class here is actually where all the interesting Redis code is going to sit. The point I'm making about the controller being blind to the implementation class means that our controller is just going to look like an absolutely, totally standard .NET API controller. It's going to look, there's nothing Redis about it, okay? All the Redis specific stuff is in here. And we'll spend most of our time here and we'll revisit here as we move through the rest of the video. So again, specify a namespace of Redis API, and again we're in data, and this time it's a public class, and it's called Redis platform repo. Now we're going to want to implement, or say that we're going to attempt to implement the interface we've just defined. So we do colon, and then we find the interface specification, which is iPlatform repo, and we're not quite good yet because it's complaining. And the reason it's complaining is because we've defined the class and we said we're going to implement this interface, but in fact we haven't done that yet. So what you can do, cursor in the offending article, control period, and select implement interface. Now, it's pretty good, but it's not clever enough to completely implement it for you. As you can see here, all it's really done is create the method signature templates and then put a not implemented exception inside there, but it's still pretty good. We still need to go in and actually do the implementational detail. Now, just before we do that, into our class, we want to make use of our iConnection multiplexer, which we set up in the previous section, because that's really the glue between this, effectively, and our Redis instance. So we need an instance of that. And the way we're going to get that is through constructor dependency injection. So first thing we're going to do before we implement these methods is set that up. So we're going to create a constructor in our class, and the way we do that is by typing CTOR and then tab. And it gives us a kind of, again, another placeholder, templated kind of constructor. And so into that, we're going to expect an instance of iConnection multiplexer. Have I spelled that correctly? Hopefully I have. And we'll just call that, let's just call it Redis. So I think we need to do at least a capital M, spelled correctly, hopefully, and then control period to bring in Stack Exchange Redis. So we're going to use a very standard pattern. We're going to assign whatever is injected into the constructor, i.e. this thing here. We're going to assign it to a private read-only field called _Redis, as so. And if you've seen any of my videos before, this will be a very common pattern. And by the way, I didn't invent this. It's a pattern that's out there everywhere if you work with constructor dependency injection. I'm not going to claim I invented dependency injection. All right. So again, it's complaining. So control period, and we want this generate read-only field. And that places that up here for us. So again, just to come back to our program class, we did wire up our iConnection multiplexer. It's registered in our dependency injection container. And so when we ask for an instance of it here, we get given it from our container, and it's assigned to this initially, and then we assign it to our private read-only field, and we can then make use of that _Redis iConnection multiplexer throughout the rest of our class. Fantastic. All right, so let's move on and start actually implementing some of these methods. So the first one we'll have a crack at is creating a platform in Redis, and you'll remember when we did the command line stuff, we used the set command to set string data type. So we're going to basically do that, but via code. All right, so let's just quickly do a check first to see if the platform object that was passed in is null or not. So if it is null, then we'll just throw argument out of range exception. And we will specify a name of plat. Okay. Fantastic. Whoop. So assuming it's not null, we want to continue on. Now, maybe before we continue any further, what I'm going to do is I'm going to make use of that desktop tool for Redis that I was talking about. And the reason I'm going to sort of have a look at this is because it gives us a nice view of, oh, that looks huge. It gives us a nice view of the kind of, not the internals of Redis, but some of how it's structured. So if I just pull this onto my screen, it's, oh my goodness, it's going absolutely massive. Let's see if I can make it a bit smaller. No. Anyway, hopefully you can kind of see that. I've got this screen magnified. So this is our Docker instance, the one we have running in Docker, and you can see that's basically what I'd call the Docker server, right? And then by default in the Docker server, and again, unfortunately you can't see all the way down, there are 16 of these databases numbered 0 all the way up to 15. And you can see that currently everything is empty. There's no key value pairs or anything in any of our databases. All right, so why they chose 16 databases, I'm not really too sure. I probably should have done that research, but by and large, they are effectively different namespaces. And by default, we're just going to put everything into DB0. You can change that, of course, but that's what we're going to do. And then as we put data in here, you'll see it kind of manifesting. Now, unfortunately, yeah, this is looking a little bit mad. It's absolutely huge. I'm wondering if I can make it a bit smaller. No, unfortunately I can't, but yeah, you get the idea anyway. So where were we? Yeah, we're coming back here. We're going to create our platform in code. So that's cool. Let's get on with that. The first thing we need to specify is we want to kind of create a reference to one of those databases, the default database. And the way we do that is by specifying a variable, and we just make that equal to our Redis instance, and we just say get database. And that will get us a reference to DB0. And you could select any one of the other databases if you wanted, but we're not going to do that. And then we're going to take our object and we are going to serialize it into a string because we're using a string data type. So in order to do that, we'll create another variable and we'll call it serial plat. And we'll make that equal to JSON. We'll use the JSON serializer. I'll probably need to bring that namespace in, which is control period, and using system text JSON. And we want to serialize our platform that was passed in. And that will then get assigned to serial plat variable. And then finally, super simple, we make use of our DB again. And this actually gives us access to a whole range of Redis commands on that DB. And the one we want is string set, and then we pass in the key that we want. So in this case, we're going to use the ID of the platform object that was passed in, makes sense. And then just the entire serialized platform object. And that's it. Now what you'll see here, when we used the set command at the command line, it was just set. The kind of, get rid of that tooltip, the kind of standard that the Stack Exchange Redis package uses is to kind of name the command set, but prefix it with the data type that it's relevant to. So it's actually quite nice. So you can tell just by looking at that, we're setting a string and the rest is fairly straightforward. Fantastic. Okay, so we'll save that off. And then we're only going to implement one other one at the moment, and the next one we're going to implement, because we're going to come back to the other one, we will implement all three. We're going to skip over the get all platforms one for the moment. We're going to leave that as not implemented, and we're just going to implement our get platform by ID. So let's remove our exception, and let's get going with that. So very similar, the first thing we want to do is define a DB. And we just make that equal to underscore Redis get database. Now we could probably, this is obviously sort of duplicated code somewhat, so we could probably refactor our class to just have one DB instance, but we'll just keep it simple for the moment and just call it again. And then we will define a platform object, because that's what we are hopefully expecting to get back. But again, we could get a null back. We may pass in an ID and we might get nothings. But anyway, we'll cover that scenario in a second. Make use of our DB object again, and we're going to use the get command. And following the kind of syntax of the Stack Exchange Redis package, it will be string get. There we go. And you simply just pass in the key, or in this case, the ID that was passed in the method, but it's basically our key. All right, excellent. So at this point, we may or may not have a platform object, so we'll just do that check. So we'll say if not string is null or empty plat. So if it's not empty, then we want to return. And again, we're going to deserialize the object because it's stored as a serialized string, and we're going to deserialize it into a platform object. So again, we make use of the JSON serializer, this time the deserialize method. What are we deserializing to? What type? We're deserializing to a platform. There we go. And what are we providing to that? We are providing our plat object, which we know is not null, so somewhat safe. And otherwise, if this condition here is not true, then we're just going to return a null, and it's going to cause us all sorts of problems, again, based on our wonderful friend null reference type. So we need to change this slightly to get rid of these warnings. We could leave it, this code will still run, I just don't like warnings. So the way we solve that in this instance, we have to do something in two places, is up here on our, when we're specifying that we want a platform back, we're going to tell the compiler, through its static code analysis, and say that we can expect this to be null. We can safely expect that to be null. That's okay. And that's cool, so that's kind of resolved that, but it's just pushed the issue further up the food chain because we're now not really, this method signature does not match exactly the method signature that we have here. So all we need to do is just update this and save it. And hopefully, well not hopefully, we shouldn't be hoping, we should be knowing what we're doing. You can see the warnings have dissipated. So again, it's just a good point. This would still have run. It was just warnings, but I don't like warnings, so we're going to get rid of those. And so we just need to use these techniques to kind of get rid of those warnings. Fantastic. So we might just do a .NET builds. Oh, actually, no, we won't. The one thing I always forget to do, and I have remembered this time, is we need to register this repository in our program class. That's the last thing we need to do. So underneath our connection multiplexer, whoop, you can really put it anywhere really. We'll make use of builder again, services, and this time we're going to add a scoped. And quite simply we say, if someone asks for an platform repo, we'll bring in that namespace using Redis API data. If someone asks for this, what we're going to give them, we are going to give them this instead, Redis platform repo. Okay, and this is the line here that you would change. So if you had an implementation class for SQL Server and you wanted to swap it out, this is where you would swap it out. And you'll see when we come on to doing our constructor, our controller, it's just making use of iPlatform repo. It doesn't care what the implementation class is. So it's very, very cool. All right, awesome. So we'll save that off. I think we'll do a .NET build. It's looking good, but we'll just do it anyway. Just to check before we move on. And we should see 0, 0. That wonderful, beautiful green build succeeded 0, 0. Fantastic. So that's our repository kind of done. We are going to revisit this, of course, because we're not quite finished, but we're done for now in terms of moving on to the next step. And that next step is wiring up our controller. So we'll move on to that now. All right, so we're on to creating our controller now. So back in our project, right click, and we're going to create a new folder in the root called controllers. And into our controllers folder, we're going to put our controller class. So platforms controller.cs. And just double check. Yep, that's spelt correctly. So starting from the top down, namespace first, Redis API controllers, and then public class platforms controller, and we're going to make use of a controller base class, and we need to bring in the namespace for that, so control period using Microsoft ASP.NET Core MVC. Fantastic. And then we just want to decorate this with API controller, and that just gives us access to a range of default behaviors for an API controller that you're probably going to want to use or have about. Next thing we're going to determine is the route to the controller itself, so the kind of base controller route. Now actually, before we do that, maybe if we just pop over to our controller actions, when we talk about the controller route, we're really, in the context of what we're looking at here, we're looking at the part of the route that is common to all endpoints. So you can see there the route that's common to all endpoints is API/platforms. Okay, and so that's basically our base route. We can define that at the class level, and then when we start getting down into the individual endpoints, if they differ from that, then we will deal with each of those cases in turn. And really the only one we need to actually deal with is this first one here, getting a single resource, which expects an additional ID or key as part of the route. Okay, so API platforms is basically our controller level route. So we'll just specify the route keyword, open round brackets, double quotes, API /. Now we could type platforms, hard code it, or what I'm going to do instead, square brackets, and make sure I put 2 L's in, put the controller keyword in here. And all that does is it looks at the name of our controller and it just pulls out this part of the name of the controller and puts it in there as part of our route. So our route actually is API/platforms. Okay, you can hard code if you want to, it's entirely up to you. All right, now what I've said a few times now already is that our controller is going to want to make use of our repository, and all it's going to be interested in asking for is our interface, the interface to the repository, because all it's interested in are what can you do for me. It doesn't care how we implemented it. So the way we do that, again, is through constructor dependency injection. So we're going to define our constructor. So again, CTOR, do you remember that from last time? Tab across, and we're going to inject in an I platform repo, not reop, repo. Okay, and we'll just call that repo. Now we don't know what this is, so control period to bring in the right namespace. And then as before, we're going to assign whatever was injected in here to a private read-only field. We'll call it _repo. Fantastic. And we'll just control period to generate a read-only field. That looks good. And just to remind you, although I'm sure you remember, back over here, this is where we registered our repository. And what we're saying here is, if you ask us for this, which is what our controller is doing, then we are going to give you this. And of course, we can swap that out as much as we like. And the controller, or any consumer for that matter, doesn't know, doesn't care. The end result might be quite different, but it doesn't know or it doesn't care. All it cares about is what can it do. So let's just save that, let's do a .NET build. And that's kind of the shell of our controller setup. That looks good. So we might just take a quick pause here, and then in the next section we'll move on to creating our 2 controller actions, which is where it gets really exciting when we actually start using Redis. All right, we're moving on to our API action results now. So let's just take a new line. And the first action result we're going to define is the ability to get an individual resource. Now, maybe before we even start that, let's take a quick reminder look at our action results here. And so yes, it's this first one we're going to define. Okay, so it's a get verb that we're going to specify. The controller level route is going to be fine, but we do need to specify the additional need to use an ID type parameter in the route as well. So we'll come on and do that now. So let's say public action result of type platform. And again, this is where I think I've mentioned DTOs before. I did at the start actually. This is where you would use data transfer objects. You wouldn't be returning back your internal model class directly, or you shouldn't really, just because you're tying your internal implementational detail to an external contract. But if you are interested in that though, my REST MVC API video, I can put a link up there and you can take a look at the DTO section. For our purposes though, it's fine, we don't really need to worry too much about it. So we'll call this action get platform by ID, and we'll expect to pass in a string that is basically our ID. And you need to specify the verb, as I've just said, so it's going to be a HTTP get. And then in addition, we want to specify that we expect to get a parameter as part of our route. So that's open round brackets, double quotes, curly brackets, and then we'll just specify that we're expecting an ID. And the other thing I'm going to do is I'm going to specify the name for this as well. And I'm just going to make it exactly equal to the method name. And you're going, why are you doing that? Why do we need that? I'm not going to explain that right now. It would be too confusing, but I will explain it in a bit. Don't worry, I'll come back. We'll circle back to it. Platform, we need to bring in the namespace, so control period, so REST API models. That's cool. Fantastic. And then, yeah, we just basically need to go into our repository and see if we have a platform that matches this ID. So the first thing we'll do is specify a platform variable, and we'll just make that equal to our repo, and we'll call the get platform by ID method, and we'll just pass in the ID. Simple as that. Now bear in mind, this could return null. Remember we engineered that that way. So let's just check to see if it's not null. So if not platform equals null, that we don't need to do that. Platform doesn't equal null, then we simply return back an OK. So a HTTP 200. And along with that, we'll pass back the payload of our object. All right, fantastic. Otherwise, we'll just return a not found 404 error, 404 response. Okay, so fairly straightforward, nothing too controversial there. Probably the only thing that might be slightly confusing is why I did this, but we'll answer that in the next section when we do our next action result. So quick pause, and let's come back and do our second action result, which is creating a resource. All right, so creating a resource, let's just take a new line, a couple of new lines, and again, it's a public action result. And we are also wanting to pass back the platform. So the idea is we're going to provide some JSON to our API, and it's going to return back that newly created platform with the relevant JSON as well as a platform object. All right, so we want to return back a platform as well. And we're just going to call this create something very original like create platform. And we are actually going to expect in as well a platform object. So we're going to specify that as our inbound payload. And again, you would use a DTO here as well, usually like a DTO, create DTO to specify your inbound payload, which you'd pass in here, and then you'd pass back like a read DTO. We're not doing that, we're just directly using the model. All right, won't mention DTOs again. And the other thing we want to do here is just decorate that quite simply with a HTTP post method. And again, although we did just look at it, just to clarify our results, our action results, we're doing the second one here. We just need to specify the verb as post. We don't need to do anything specific around the route because it's just going to inherit the controller level route that we've already specified. Okay. And then in terms of our repository repo, all we need to do is just call the create platform method on that, and we just pass in not a 0, that wouldn't make any sense at all. We are going to pass in the platform object. Okay, and then the second line, and this is probably the most complex line in this whole controller code, we're going to return, not the return statement, that's not complex at all, but we're going to make use of a method called created at route. And it's this created at route method that's going to make use of the name of this action result. And what this is doing, as I've sort of said already, is when we successfully create a platform in our Redis database and we want to pass it back, so we want to pass back the JSON payload, but as per the REST specification, we also want to pass back the URI, the resource locator, for that individual resource as well. So we use this created at route method to do that, and we pass it, number one, the name of the route that we can use to retrieve our resource, along with the ID, which is the unique component, and as well as the object itself. So we'll do that now. So created at route, so the first parameter we want to pass in is where the URI effectively of where we can get to this resource. So we're going to use name of, and then we just pass in the name of this method here. Okay, that's basically telling us where we can sort of get it. We then need to specify the ID that we're going to use as part of that route. So new And we'll just specify ID equals, and we'll use the ID on the platform object that's being created. And then finally, we just pass back the entire object itself. Okay, so get a few questions about this. Hopefully I've explained it well enough. You'll see when we actually come to creating it, how it manifests, and it might make a bit more sense then. And that's it. So, I mean, obviously we're going to come back to our controller code. We will revisit it because we're not completely finished, but these two action results, unless I'm wrong, are pretty much done. We don't need to change these. We will be changing our repository a bit later, but we don't need to change these. These stay the same. That's the beauty of using an interface. Anyway, we are going to now come on to testing this and seeing if it all works and seeing where, if any, mistakes that we've made. Hopefully not, fingers crossed. So we'll come on and test this, and then we'll move on to the next section. So we'll do that next. All right, so the moment of truth, we're going to test our API. So .NET run to run it up. Fantastic. And I'm just going to copy this base URL here. And I'm going to use Insomnia to test our API. Now, I think I mentioned in the introduction I was maybe going to use Postman. That was just a slip of the tongue. For most cases, I will use Insomnia. I just like its interface more. It's a bit cleaner, it's a bit simpler. Postman's excellent, by the way, but it's probably got too many features for me, and its interface can be a bit confusing. I like this, it's just a lot cleaner. All right, so the first thing I think we should do, because our Redis instance should be empty, and if I show you my this tool I use, it's going to look fairly massive on screen, but it doesn't matter. Our DB0 is empty, and if we refresh that, there's nothing in it. Okay, so we're starting from a clean slate. So what we should do, I think, first is create a resource in here. So let's say create platform, and it's a post request, obviously, and the body is JSON. All right, so that should hit our route. So let's just paste that in here, and we need to specify this API and platforms. So yes, post request, this is our route, should hit that create action result. And all we really need to do is just pass in some JSON that we want to, use to create our object. So we specify the name, and let's christen our API by saying Redis is our first platform. Now you'll notice we're not specifying an ID here, and you'll remember that is because we come over to our platform object. We are generating a unique ID or key. Let's try and remember to use the Redis terminology. We are generating a unique key ourselves here. Nothing to stop you not doing that here and passing it in via the API. You could do that, but we are, we're choosing not to do that. All right, so let's see if this works. Let's click send. And there we go, we got a platform back. So that's looking very exciting. So we get the full JSON body, including the ID, which you can see has been constructed for us. In the header, you'll see we have this location attribute, and that is the route to this unique resource. And again, coming back to our code, this created that route method. This is really what this part is doing here. It's returning us back where we can get the resource and, of course, the ID of it, so we can uniquely get back to it. So what we can do actually is take a bit of a shortcut, and we'll create a new request, and we'll just call it get platform, get request, create, and we'll come back here and we'll just copy this here straight in to here just to test it out. There we go, all works fantastic. Now the only thing you might notice is that it's done some sort of string encoding. It's removed the colon, well, not removed the colon, it's re-encoded the colon as whatever that was. Let's just try it again. Yeah, it's fine. So what was the code? It was, %3a. Okay, so it's kind of URL safe. Doesn't matter, you can use either here, it works fine. So you can see, yeah, it's all looking pretty good. You can see it's pretty damn fast. Look at that. It's fairly fast. Now you'd expect it to be. There's only one thing in the instance and it's running locally, but it's still, it's very, very fast. All right, so what we might do is if we come over to Redis in our GUI instance, I'll just refresh it. And you can see here, we have in our DB0 instance, we have one key value pair. And you can see here, it's got the full name. And then this might be a little bit difficult to see. Whoop. Excuse me, let's move this over. You can kind of see what it's telling us. It's saying it's a string, and I believe that will be the key in here. Yeah, there's a key, and then the actual value. So the string value, or the string key, and the actual value that it contains. All right, so let's add one more, because I want to just show you another thing about this tool, although it's probably a bit difficult to see. Let's create another platform, and we'll call this one Docker. Actually, let's create a few. Send. Let's create another one, we'll call it Kubernetes. And let's create another one, and we'll call it, what will we call it? I don't say Terraform. It doesn't really matter. Just trying to think of things I've used in my other videos. All right, so that's all looking good. We don't have a give me all these platform endpoints yet. We'll come on to doing that next, and we'll have a bit of a discussion around that. But what I wanted to show you just before we move on to that section is if we come back here, and again, this is very unique to this tool, but what you can see it's done is it's kind of grouped, because we have 4 platforms now, it's kind of said, okay, these are 4 platforms, kind of the name, I'm getting tongue tied, kind of the same namespace, platform. Everything's prefixed with platform : so it groups it under basically a namespace. Okay, so I like that about this tool, that it does that, and you can just navigate through and look at the values of it. But the point I'm really making here is that's kind of why we structured our keys in such a way, because other tools and other platforms will do something similar to this. They will, the use of the colon in the prefix kind of allows you to organize your keys in a bit more of a structured way. Okay, so that's really the point I wanted to make here, and hopefully this is now starting to, you know, percolate in your mind how this is structured. But again, this is purely a user interface rendering. The key itself is still absolutely platform : GUID. It's just rendering it in a slightly nicer way. And you'll remember actually when we just had one platform in here, it had just rendered it as the one thing. All right, cool. So very good. We can sort of start to get to a point where we're saying, yeah, you could absolutely use Redis as a primary DB. So far, it's all working brilliant. But what happens if we want to return all our string-based keys back? I wonder if we're going to run into any potential roadblocks. Maybe we will. So quick pause here, and we'll come on and we'll talk about how we can achieve that endpoint in the next section. All right, so we're going to come on and look at implementing our third endpoint, which is retrieving all our resources. So the third one that you can see on screen there. Now, just in the last section, I was saying we might run into some problems. Yes and no, really. So what I was alluding to was the fact that we are currently using strings. So when we create a resource, we're using the string data type, and when we're retrieving the resource, we're using a string data type, and that all works really nicely. When it comes on to retrieving all resources stored as strings, you can do it. You can absolutely do it. And in fact, the command that you would want to use, let me just bring on the Redis documentation on screen, is something called scan. Okay, so this command absolutely does exist, and I'll actually show you it working. We're not going to implement it in code, but it does exist, and you can scan for all your keys basically, and it'll pull back your resources. And I actually did play with this, I did implement it in code. It does work, but for a couple of reasons I didn't really like it. And the first one was, well, I actually wanted to explore other data types. The second one was, I felt that it wasn't particularly optimized for speed. The way scan works, it's a cursor-based function, and you may have to start dealing with cursor positions, and it doesn't guarantee how many results you're going to get. It all works and everything, as everything in Redis does, it works really nicely, but I just felt it was a wee bit clunky. I didn't really like it. It didn't resonate with me. So that was the two main reasons. I wanted to use some other data types anyway, and it felt a bit clunky. It does work though, it's fine. So if you want to go with a pure string-based approach, this is perfectly acceptable. The only other point I'll make is that it kind of works at the server level. So in fact, there's another article here from the guys who created the Stack Exchange Redis package, and they actually sort of start talking about this when you compare running stuff at the database level versus running stuff at the server level. And it's all a little bit, the pattern's a bit different as well. When you start coding up this scan command, it's a little bit different, and I didn't really like it. So that brings us on to thinking about some other ways of doing it. Now, just before we do that, I'm going to demonstrate the scan command to you, just so you can see it working. And there's another reason I want to show you the scan command as well. So back over in our project, if we come back into our Docker instance. Now, if you don't have this running, that's okay. You'll just have to do some stuff at the command line. But I'm going to attach to a shell using the GUI, using the interface attach shell. And you can see all it's actually done is just done the command that we've run before, which is that docker exec-it. And they're using a slightly different IT for the container, but you remember we did it earlier. You would have to run that same command again if you don't have this tool. So we're attached to our Docker container, so all we have to do is run up the redis-cli. And we're at the redis-cli, so just do a quick ping, although we know that's going to work, and we get a pong back. Brilliant. So the scan command, you type scan and then the cursor that you want to start from. So it's a zero-based cursor. So we'll say, give us, this is really attempting to give us everything. And it brings back our 4 keys anyway, and you can build the scan command out so you actually get your values as well. So it does work. It's okay. I just didn't really want to use it. So yeah, I did write the code for that, and if I remember, I'll put that code up on GitHub as well. Now, the other thing I wanted to cover, and I'm just going to use the scan command to demonstrate it, is that one of the reasons, again, the whole reason for this video is, should we be using, or could we use Redis legitimately as a primary database? And one of the major concerns people have, or misconceptions people have, is the fact that as Redis is an in-memory data store, if it rebooted, you would lose all your data, and that really doesn't lend itself well to being a primary data store. That's not true. I mean, it is an in-memory data store and it is super fast, but it also does persist data down to the disk. So if it reboots, the data is still there, it'll just be reloaded into memory. So I just want to demonstrate that, just to show you that, because we're not really covered that off as a point of note. So again, I'm just going to stop this container using the GUI. If you wanted to use Docker compose commands, it'd be Docker compose stop to stop it. Now we've stopped it, you can see there it's stopped, and we've lost our connection to our terminal, which is actually a good thing. So we'll just restart it. So we've stopped it, and we'll restart it again. And then we'll just reattach shell. Fantastic. Go into the redis-cli, and we'll do scan 0 again. Oh. And our 4 elements are still there. And I could bring up that other tool, or we could run our API, and those 4 elements are still there. So I just wanted to cover that off as a kind of tick. Yeah, it is, the data is persisted. You don't lose it, even in the event of a reboot. Cool, so what we're going to come on to next is we're going to use a different data type to attempt to implement our get all command. So I'll just take a quick pause here, because I've thrown a lot of information at you there, and we'll come on and take a look at what that approach is. It's not our final approach, but we're going to do it anyway, just to exercise some different data types, and we'll see how that works. And then in the last section, we'll do our final implementation, where you just use the one data type to do everything. But anyway, quick pause here, and we'll come on to our next approach to dealing with retrieving all our platforms. All right, so we're going to, keep going with attempting to get all resources, implement our get all resources endpoint. So this is what I've tried so far. I've talked about the scan command, which we're not going to implement, but if you are interested, I remember, I'll put the code on GitHub and you can take a look, and you might want to use this approach, it's up to you. What we're going to do next though is use sets as well as strings. So we're going to take a bit of a hybrid approach to working with, or to building an API. So what that means in practice is that in terms of our repository methods, the existing getPlatformById method, which currently uses a string data type, that's going to continue to work exactly as is. We're not touching that. But we are going to implement a new repository method, getAllPlatforms, and that method is going to return an entire list of all members of a set. Okay, and so what that means in order for that to work is our create method is going to have to create 2 things. Number one, as it's doing just now, it's going to have to create a string. Number 2 though, and this is what we're going to introduce now, it's going to have to add that platform object to a new set data type. And that means we can then implement this 3rd method. Now straight away, you're probably going to be going, that sounds really horrible. Do you know what? Yeah, It is, but again, it's just part of this exploration of using different data types to see what they can do. So again, we're not settling on this, but we're going to have a look at it, see how it could work, and then we're going to move on to the final section and come on to our final implementation. Right, so cool. I just thought I'd explain that, and we have a third option here, but I'm not going to reveal that just yet. But what I will do is just clarify and go back over the string data type, which we've already done, just to refresh our memory. So it's the simplest type of value to be associated to a key. One-to-one mapping, useful for a number of use cases. We've gone through this already, using set and get. So this is what we already have, and you can see it's a one-to-one mapping. To talk about sets, which is really what I want to talk about now, it's an unordered collection of strings. So it's a one-to-many mapping between a key and a value. So we're going to create a set next, and it's just going to have a key. And then the values inside of that are going to be our individual platform objects. So this lends itself very well to just going, give me all members of that set. Now, it can do a lot more than how we're going to use it, but again, it's part of exploring what these data types can do. Yeah, so you add members to a set using SADD. So for example, you could add the elements 1, 2, 3 to a set called mySet, and then you can return all members of a set using smembers mySet. And you can also check to see if things are members of a set and all that kind of stuff. So sets are good for kind of almost constructing relations between other entities. They can be used for that kind of thing. And yeah, you might ask, could we not use a set? Could we not use this pattern to get an individual resource? No, you can't. You can't actually use it to do that because there is only one key. Now you can start dipping into the members and stuff like that, the values, but it doesn't really work, at least not as far as I could tell. So that's why we have this hybrid approach of maintaining strings for individual responses and this method for every response. It would be lovely if you could use this to get an individual element. You can't, based on a key, as far as I can tell anyway. All right, so on to the code. So back over in our project, I'm going to disconnect from this first. Exit out of that. And return back to the command prompt and come back over into our code editor. And then we just want to ensure that we are in our Redis platform repo because that's where we're going to be making the change. And we're going to come in first of all to the create platform method. And we're already, as you know, creating a string here. So all we need to do here to update this is again make use of our database. And instead of string set, we're using sets now. We're going to use set add. So it's not set. set would be a bit weird. It's set add because we're adding a member to a set. A set contain, again, a member, lots and lots of unordered strings. So it requires a key, all right? So one set will have one key. So we can basically give this any key name we want at all. So we'll call it platforms set. Maybe take out the S. Platform set's good enough. And then all we pass in here is, again, the serial plats object. It's that simple. And that will then add, anytime we add a platform, it will add to a set as well. So let's just test this. Okay, so I'm going to save that off. Now, again, with .NET 6, you can actually do a .NET Watch to do a hot reload. I'm just not getting into the practice of using it, so I'll stop our server and we'll do a .NET run. .NET run. But yes, .NET Watch allows you to do this kind of hot reload stuff, but I'm not really into using that just yet, but it is definitely available. Okay, so we've applied our changes to our Redis platform repo class. So what we'll do is we'll come back over to Insomnia and we'll create another platform. Okay, so here's our Insomnia instance. Oh my goodness. I think I've said I've got this screen magnified and I just find magnification screws up anyway. It's not going to bother doing that. I'm trying to resize this, but it's not really working for me. I think because the screen's magnified. So let's create another platform. I don't know. Exchange. Microsoft Exchange. Doesn't really matter. So we'll create a new platform. Cool, we've got our platform created as before. If we come back over to our RDM tool and we take a look at what we've got, what you can see here is we have our list of platforms as strings as before, and this was probably the last, no, I don't think it's particularly ordered. Kubernetes, okay, yeah, it's ordered from, no, looks like it's completely randomized, that's fine, maybe it's based on the keys or something. So you can see here's the string data type that we're using and existing, and that's all fine, that's going to work, but we now have our set, platform set. So we click on that, you can see how that looks. It's a set data type called platform set, and we have one object in there, which is our exchange object. Now straight away you can see, well, these are now out of sync. You know, we've got 5 in one and 4 in the other. Now you'd have to clear down everything and resync them. That's not a big deal. And let's add another one. We can just see this again, see this working. Exchange. I don't know. Let's just say XML. Doesn't really matter. XML is not really a platform, but no, it doesn't matter. Right, pull it over, refresh this. You can see again, we get 6 in here, and we'll now have 2 items in our set. All right, so again, it's not working exactly as we'd want it, but again, we would just reset everything. Now, it's worth noting, and I've not implemented it because, yeah, we're not going to go with this approach in the final analysis. You can, in Redis, kind of contain things in a transaction, so you can ensure that both of these commands would run together. So you're not going to get things that are out of sync, you know, because the last thing you'd want in this approach is you have, yeah, as we're seeing at the moment, things out of sync. You want to have exactly the same stuff in each one. It's not a nice approach, and I'm not advocating it as an approach, but again, it's really just to show you the use of sets working. All right. Now, what we really want to do is we want to implement returning all items in our set. So we'll come on and do that now, and come down to our get all platforms function, and we'll write some code to pull back all the platforms in our set. Now, it's only going to return 2 for obvious reasons, but again, we'll just have a go and see how that all works. So let's take this out, and we're going to, again, create a DB instance, var db equals underscore redis get database. As before, we probably want to deduplicate that code. Anyway, we're going to pull back our complete set. So we'll say var complete set equals db, and this time the command we want is set members. Okay, and then we just supply the name of the set key, and I can't remember what we called it, platform set. There we go. We'll just copy that in here. So it's saying just give us everything in that set. All right, so we'll do a quick check to see if the complete set length is greater than 0, which means we have some members. If not, we will just return null. All right, now again, this is warning us because we had said that this cannot return anything null, so make use of our friend, the, I was going to say exclamation mark, that's not an exclamation mark, what's that? It's a question mark. And then we have to come back into our repository interface and do likewise up here. And we'll save that off, and that should get rid of that warning, hopefully. I actually think we need to double up here. Like that, and then do that as well. That's better. Okay, so double up. All right. So assuming it's, and again, you know, to my point about having these warnings, they're good, but they can be a wee bit annoying as well. Anyway, assuming we do have something and we don't have null, then what we want to do is we want to kind of iterate round our result set and return it back as a collection or an enumeration of platforms. This next line is a little bit convoluted. I'm going to type it out and hopefully it makes sense, and we'll go through it. So we're going to use an array object to convert all, and we're going to use our completed set, and then we're going to use a lambda expression And we're going to deserialize JSON serializer. And what I might do is do a Control B to take down our file explorer so we can see everything on screen. We're going to deserialize to what? Platform. Pass in val, and then we'll mark that to list. So a bit of a monstrous line, but basically this set members, if we actually come over and we take a look at what it returns, if we just maybe hover over, yeah, you can see what it returns. It returns an array, basically. So we need to convert that array to a list, effectively, is what we're doing here, which, you know, works with our enumerable, and we'll return it. Return obj. We'll return that object. All right, cool. Save, and stop and restart our API. And actually that's not going to work because we've only done our repository, haven't we? We've not implemented our action results. So actually let's come on and do that before we forget. So may as well stop this. I'll bring up our file explorer by doing a Control B. And yeah, we need to come back into our platforms controller because we've only implemented 2 endpoints. So let's do our third one now. So new line, we'll do the method first, which is just a HTTP GET, and coming back to our list of endpoints. Again, you're probably sick of seeing this now. We're just doing this last one. We're just using the controller level route, and it's a GET verb, so we don't really need to specify a route. So HTTP GET's fine. And then it's a public action result. And what is it returning? It is returning an enumerable of platforms. Don't pluralize it, platform objects, and we'll close that off, and we'll just call it get platforms, get all platforms. Make it a bit more meaningful. And we don't need to pass anything in. And it's pretty simple. We simply return OK on our repo, calling into our get all platforms method. It's a pretty simple one. Okay. Fantastic. Save that off. Let's restart this, and it should be working. Sort of. So in Insomnia, I'm going to right click, new request, and I'm going to say get all platforms. Get request, create, and I'm just going to copy, there we go, I can make this a bit bigger here. That's better. I'm just going to copy this, because we don't want a URI, we don't want our ID, and that should pull back, here we go, 2 objects from our set. So it's not pulling back 6 objects, 6 platforms, it's just pulling back the 2 that exist in the set. So it does work, it's very quick, you know, and I've not done it in this video, but I actually pumped thousands and thousands and thousands of randomized platforms into this, and it's still mega quick. And maybe I'll do another video on how I did that, how I used, how I pumped stuff into it. It's still mega quick. Okay, so actually, it's not the best implementation by a long stretch, but its sets are really quick. Really liked it. Anyway, that's sets. We're not settling on sets. We're going to move on in the next section, in the last section, to refactoring our entire repository to use just one data type. So we'll come on and we'll do that next. All right, so let's just move on to the final part of implementing get all. And we'll take a quick look at what we've done so far. So, well, we haven't really done the scan command, but we've given an overview of it and why we're not using it. We've just used sets, fantastic. Now we're going to move on to refactoring our entire repository using only hashes. Okay, so we're going to move to one data type, the hash, which sounds amazing. So let's just take a quick look at what hashes actually are. So need to be careful with my language here because it gets a little bit more complex. So it stores values as field value pairs. Okay, so we have a key that we've been talking to date about key value pairs. The key is still there in hash, but just forget that for a minute. But looking just at the value component, it stores it as field value pairs now. All right, so suitable for storing structured objects, so it's kind of perfect for us. So this is the kind of layout. So each hash will have a key, and then inside it can have multiple items, each with a field and a value. Now the way we're going to store our platforms in a hash is we're going to have a platforms hash, and I'm going to call it platforms hash. I just called it platforms here. And then in the field, we're going to have the ID, and in the value, we're going to have the whole platform object. So what this means is that we can set individual items in our hash using HMSet. So that's if you're doing it at the command line, that would be the command that you'd use, HMSet, with the ID of the hash, the field value, and the value. You can get all items. So again, command line is hgetAll. So that's good for our get all use case, fantastic. And that's how you would do that, hgetAll, the ID of the hash. And then you can also get individual items within the hash, and you would use hget in that case. And so you can then drill in to individual specific items using hget, ID of the hash, and then the field value, which in this case will be the ID of our platform. All right, so hopefully that made sense. If not, the code should clarify things. So back over into our project, I'm going to stop the server from running. Now, just a point of note, while we're in the controller, we don't need to touch the controller again. The controller code is written against our repository spec, repository interface. We're now refactoring our interface, the concrete implementation class of our interface, but the repository does not, the controller does not care. It's already written, it doesn't care that we're doing this. So again, another real benefit of using the repository pattern with a nice interface. So in our concrete class, this is the only place we're going to be doing any changes. So let's just work from the top down. So in our create method, we're just going to comment out the use of strings and sets, because we're going to move completely away from that. And we'll make use of db hash set, where we set our hash object. So the first thing we need to supply is the key, and I'm just going to call it, I don't know, hash platform. And then the next thing is a hash entry, which is basically going to be our field value pair. So we'll say new hash entry, and I might take a new line, bloody tooltips, and we will specify that. So curly brackets, new hash entry, and then round brackets, and the first thing I'm going to specify is the ID, which is going to be our field, and that's just going to be equal to the platform ID, which we passed in at the top here, and then the full value is just going to be the serial platform. Okay, that's basically it for our create method. So we could leave these in and we could continue to add strings and add sets, entirely possible. I'm just going to comment them out because it could get a bit confusing. So we'll save that off. We'll move down to getting all platforms now, which is the next one in our list here. And I'm going to copy from here and just comment this out because we're not using sets again. So this is us getting everything in our hash. So we're still going to put it into something called complete set, just so we don't have to change the code. Maybe we do. Maybe that's a bit confusing. Maybe we say complete hash, which is what this video is. It's a complete hash. And then we'll just go through and change these here. Okay, I think that looks better. A bit more meaningful. Yeah, that's cool. And what we simply want to do is db it's hash get all. And all we have to pass in is the name of our hash key. Or our hash key, not the name of our hash key, the hash key itself. Perfect. Okay, now if we save this off, I think we're going to get an error down here in our kind of deserialization place. Here we are here. For val, we do just need to qualify what it is we're actually deserializing, and that is the value of our hash component. So we have the field and the value, so we're just deserializing the value part. Fantastic, so that should get rid of that error. Wonderful. And you can see we're not actually doing too much code. You know, the code is not changing too much. And this is our individual get platform by ID. So again, we don't need to, I'm going to copy this. And I'm going to comment this out. And I'm just going to make that equal to db hash get. And into that we expect the redis-cli, which is up here, hash platform. And we also want to specify the field value, which is ultimately the ID of our object. And that is just ID that's being passed in here as part of our method. And the rest remains the same. So not a lot of refactoring, but enough. So moment of truth is running up, .NET Run. And bear in mind now we're working completely with hashes, so there's effectively nothing in our Redis instance. Although we've got stuff stored as strings, we've got stuff stored as sets, irrelevant now. So coming back to Insomnia, if we do get all platforms, we should get nothing. We get no content, fantastic. This is not going to work, it's just going to return a not found. Perfect. So let's start again and we'll christen our new hash based implementation by making Redis our first platform. Not forgetting to put the double quote in, so cool, that's a good sign. We get a created result back. Let us copy this and paste it into our get platform method. That should pull back our platform. It does. And get all platforms will return all our platforms and we just have one. Fantastic. So let's do Docker create. Fantastic. Get all platforms. Get all platforms. Returns both our objects. So the last thing we'll do is we'll just take a quick look in our tool here just to see how that looks. So we'll do a bit of a refresh on this. And we have this hash platform, and then you can see inside our hash platform, it's a type hash, and we have our key, and then it's a bit difficult to see on this tool, unfortunately. I do apologize. In fact, maybe we change the screen resolution, maybe we can do that. And we can see how that looks. It's doing it on my other screen, but that's okay. Let's set the screen resolution down to 100. I think that's done it. Fantastic. And we'll bring our tool back on. There we go. That's a bit better, isn't it? And we can see the whole thing. So you can see here that we have our key. I can't actually adjust that, but anyway, you can see it here. You can see it here. Here's our key, and here's what's stored in the value, which is the object. So all looking pretty good. So that's it for the code. I hope you enjoyed the video. And, you know, in answer to the main question, should you use Redis as a primary DB? Well, like anything in the IT industry, the answer greatly depends. I think you can, but it depends on what you're trying to do. Now, we've kind of created a very simple API here, and yeah, you absolutely can use it. It doesn't mean to say Redis is the best option in every case, but in some instances, it absolutely would fit really well. And what maybe didn't come through in today's video is just the utter speed of this thing. And it's really evident when you pump more data into it, just how quickly this thing responds. It is insanely fast. So I really like Redis. By the way, I'm not sponsored by Redis or anything. This is my own opinion. I think it's a great tool. And the other, just as a side, a couple of things. The Redis documentation is excellent. A lot of technical docs can be boring, badly written, confusing. Redis documentation is awesome. It's really easy to follow. It's great. So I really recommend you take a look at that. And the other thing with Redis is it just works. I mean, a lot of the time when you're playing with something new, you try and you error and it doesn't work exactly as you think it would. With Redis, it just works kind of almost exactly the way you expect it to work the first time, which is really, really rare. So big advocate, big fan of Redis. So yes, absolutely, I think it would be a great choice for many projects as your primary database, but that's not discounting all the other options that you have out there. And we're very lucky these days because we've got so many things to choose from. And it's really your job as a developer to pick the best tool for the job. Anyway, hope you enjoyed today's video. Thank you for watching, and I'll see you again next time.